Hello and welcome to the straight line section of Higher Maths. This section just builds upon our National 5 knowledge. So if we're strong with our National 5 knowledge, we will probably find this one reasonably straightforward. So today we're going to have a look at the first topic, which is parallel lines. We're going to be working from our textbook attempting questions 13A, 1, 2, 3, 6 and 7. Of course you can do more than that if you want, but those are the questions I have written out solutions for. And you guys can access that by going to madrasmaths.com, clicking on the revision button and then higher, and the answers will be there. Okay, so that's full work solution. So if you're making a mistake and you don't know where you've gone wrong, you can just self-correct. And if there's something you really don't understand, that's the time to get in touch with your teacher. So let's have a look. So gradients. First of all, how do we find the gradient of a straight line? Well, we should know this from National 5. It is the change in the vertical height divided by the change in the horizontal height. So if we're using the gradient formula, when we do y2 minus y1, we are just finding the difference between the height of the second coordinate and the height of the first coordinate. And in a similar way, the change in the horizontal distance, that is what we are calculating when we do x2 minus x1. Okay. So we should know this. For a positive gradient, the line will slope upwards from left to right. For a negative gradient, the line will slope downwards from left to right. Lines parallel to the x-axis have a gradient of 0. So here's x and y-axis here. So these two lines I've drawn on that pass through the y-axis at 2 and at -1 both have a gradient of 0. Now the equation of this line is y equals 2. Why is the equation of this line y equals 2? Well, let's have a look at every single y coordinate on this line. This point here would be 0, 2, then 1, 2, 2, 2, 3, 2, 7, 2, 9, 2, 11, 2, -1, 2, -15, 2, -27, 2. What's common to all of those coordinates? The fact that the y coordinate is 2. So we name that point, that line, sorry, y equals 2. And let's have a look at this line down here below the x-axis. It's going through the point, it's crossing the y-axis at -1. So every single point on this line will have a y-coordinate of -1. So the equation of this line is y equals -1. Okay, the x-coordinates change all the way along, but the y-coordinate never does. So we'll call it y equals -1. In a similar way, lines parallel to the y-axis have an undefined gradient, so it's infinitely steep. So let's have a look at two of those lines here. So here, again, let's look at some coordinates on this line. So we've got 5, 0, 5, 1, 5, 2, 5, 5 up here, 5, 10, 5, 15, 5, 20, or 5, -1, 5, -2. So every single point on this line has an x-coordinate of 5. Okay. So the equation of the line is x equals 5. And in a similar way, every single coordinate here would have an x-coordinate of -2, so the equation of this line is x equals -2. And we've looked at gradients there. Two distinct lines are said to be parallel when they have the same gradient, or when both lines are vertical. Okay. So if I drew a line parallel to this line, it would have to have exactly the same gradient. If it had a higher gradient, or a larger gradient, it would be steeper. If it had a smaller gradient, it wouldn't be as steep. Okay, so let's do a couple of questions related to that. So parallel lines have equal gradients. Question number 1, consider the points ST, U and V show that ST and UV are parallel. So we know parallel lines have equal gradients, so let's find the gradient of each one. So M, then subscript ST to show we're finding the gradient of the line ST. So don't just write M and M for the other line, write MST, MUV and use subscript. So the gradient of line ST, y2 minus y1 over x2 minus x1, or if you're using delta y over delta x, that's fine. So it would be 9 minus 5 over 5 minus 2, which turns out to be 4/3. So just to make things foolproof there, guys, I've written x1, y1, x2, y2. If you're very strong with this already, there's no need to do that. If you do make little mistakes and get your numbers jumbled up, just do that. It makes it almost foolproof. And then for the gradient of the line UV, 4 minus -4, 3 minus -3, 8 over 6, which cancels down or simplifies to 4/3. So what did the question say? Show that ST and UV are parallel. So we just need to show whoever's marking or looking at our work that we understand that those lines are parallel. So the gradient of ST equals the gradient of UV, therefore ST and UV are parallel. So make the statement and show that question. Show that you understand why they are parallel. Next question, find the equation of the line GH which passes through the point 4, -2 and is parallel to the line RS with the equation 3x plus 2y equals 7. So it passes through this point and it's parallel to the line RS with this equation. So if I can rearrange this into the format of y equals mx plus c, and then I will find the gradient of that line. So 3x plus 2y equals 7. Let's subtract 3x from both sides. Divide every single term by 2, and the gradient of that line is -3 over 2. So the gradient of the line GH, which passes through the point 4, -2, will also be -3 over 2. Right, new equation for the equation of a straight line. Y minus b equals m bracket x minus a, where a and b are the x and y coordinates of a point on the line. So here a is 4 and b is -2 and m is the gradient. So at National 5 we were using y equals mx plus c, and that was fine, but at higher we generally use this equation. If you really want to stick with y equals mx plus c, that is fine, but I would suggest that you just start using this equation. Okay, you get plenty of practice at using it. You'll be fine after a couple of shots with it. Right, so y minus b, so what was b? B was -2. So y minus -2 equals m, which is -3 over 2, bracket x minus 4. So let's just tidy up this minus -2. So that would be y plus 2 equals -3 over 2 x minus 4. So step by step. Right, at this point, we could multiply out, but that would introduce some fractions. And if we can avoid that, we should. So let's avoid that by doubling the left and right hand side of the equation. So essentially when we're doubling both sides, we're essentially cross multiplying this 2. So it'll be 2 bracket y plus 2 equals -3 bracket x minus 4. Okay, so that 2 has basically come up here and we're doing 2 of everything. The reason why we can do that, we're doubling this side and doubling that side. So if we double 3 halves, we get 3 of whatever it was, or -3 of whatever it was, and on this side we'll have 2 of whatever was there. Okay, but again, that's a National 5 skill. We should be okay with that idea. Expand the brackets. Tidy up the constant or number terms on both sides, so subtracting 4 from both sides. So 2y equals -3x plus 8. We could leave that as the final answer, that's totally okay. I'm going to add 3x to both sides to get 3x plus 2y equals 8. We like the look of that. We have integer values or whole numbers for every single term. We have all positives, which we also like. If we wanted to, we could write y equals -3 over 2x plus 4 by dividing every single term by 2. That would also be fine. Any three of those are absolutely okay. We could also write 3x plus 2y minus 8 equals 0. Again, that would be 100% okay. We do not always need to write our answers as y equals mx plus c at higher. That is not necessary anymore. Okay, so that is the parallel lines topic covered. So have a go at the textbook exercise 13a questions 1, 2, 3, 6 and 7.